And welcome to NASENI Milestones, a place to be for all you need to know about NASENI's efforts towards ensuring that Nigerians understand that science and technology hold the key to national development. Today, we shall visit the Prototype Engineering Development Institute, PEDI, Ilesha, to bring you more of the astounding works of the Research Institute, which I believe you will cherish. The Institute possesses a good number of precision machines and other equipment designed for production, each performing different functions. The machines work in synergy from design to finished products. The system allows for a perfect finish and improves productivity, which is the most important direct consequence of innovative technology. The engineering personnel of PEDI would now give us details of the machines and how they are deployed for production. Thank you for joining us on the program. My name is Kierian, Umeayo, and this is NASENI Milestones. First, we begin with PEDI's Mechatronics Laboratory, fully equipped for training on emerging technologies and on advanced manufacturing systems. It consists of modular units of factory automation systems. Here is Engineer Femi Omole for further explanation.
This is Mechatronics Laboratory, and what we have in this laboratory is a modular unit of factory automation systems. These equipment are equipped with features and the capabilities of industrial mechatronics system, and we use this equipment for training, hands-on training on emerging technology of the advanced manufacturing systems such as robotics, PLC, that's programmable logic controller, on artificial intelligence, on motors and controllers. We use it for training on sensors and measurements. We use it for training on CNC and other emerging technologies that you can have, such as pneumatics. So in this system, we find out that these technologies are very important to manufacturing industries and the processing industries, such as the petrochemical industries, the consumable manufacturers. We find out that these technologies are very useful to industry like the maritime for cargo handling, and it's equally very useful for other industries like the refining industry, the food and beverages, and the likes. So we use the hands-on approach of training for participants using this equipment, because the hands-on, we realize that it gives them better understanding of the technology concept itself, and it equips the participant for an employable skill. It makes them readily employable with the skill they will get from here. And for professional participants too, we discover that it will enhance their technical know-how. So, and we have recorded a number of training for participants in these laboratories. We have trained players in the industry using this equipment, and we have also seen students and lecturers of higher institutions come here for training as well to have these skills. We have had the opportunity of training the Nigerian military personnel too with this equipment, and we have a number of collaborations too with players in the industries. And again, we render consultancy services on this equipment and on the technology. So we believe what we give here will be of value to whoever comes, and we will love to have you too as one of our participants, and you will have value for what you get from here for yourself and for your organization.
At PEDI Manufacturing Services Department, where research results are translated to products, can boast of some machinery for value addition to rice and other agricultural produce. The department also manufactures other machine types as well as equipment for the provision of certain services. Engineer Oyekola Oduola is our guide. There are assorted types of industrial spare parts as explained by Engineer Oduola.
The primary function of the department is to convert or translate the results from research and development activities into physical products, making use of facilities we have seen the past few minutes installed in the various sections and laboratories. For instance, on display here are products developed over the years by the institute. The first one on display is the rice milling machine, which is the very important equipment in the value addition chain for rice production. You have the rice destoning machine, another important equipment in the value addition chain, followed by rice polishing. These three machines are for rice production to improve the quality of rice before being taken to the consumer. Again, another agro-processing machine on display is the oil expeller for groundnut oil. You harvest your groundnut, you roast, and put into the machine, and at the end of the day, you have oil. For the building and construction sector, we have a vibrating brick making machine that runs on generator or PACN source. That's for the building and construction industry. This item here, this product, this is a cash tank for Central Bank of Nigeria. Hitherto, the item was being imported, but now the institute is in a position to supply quite a number of these to Central Bank. And over the years, we have supplied a sizable number to Central Bank in Akure and Benin City. This is laser engraving machine for making prints on non-metallic products. It could be used as a teaching aid in universities too. This is a 3D, three-dimensional printer for making plastic components. The beauty of the machine is the products, the components of the machine are assembled to make the machine itself. And apart from the components of the machine, you have gears like this from print photocopy machine and a number of other components from different machines. It runs on plastic. So this is automated electric deposition machine for putting finishings on machines from the workshop. This is OBD, onboard diagnostic scanner, produced by PEDI engineers. It is for the transport sector, and from the name, OBD, onboard diagnostic, is for fault finding. You connect this to the engine of your motor vehicle and this to the computer system. So you can easily find out what the faults are on your vehicle, and it's any vehicle made from 1996 upward. Different industrial spheres for different companies in the manufacturing sector. For instance, look at this. This is a side disc, and it is for turbine, power generation. This other component here, this is a blade for Nigeria Poultry Company. This is another component for the National Bureau in Ilesha, and so on. So each of the components or spare parts you are seeing on the table is for different manufacturing industry.
Different types of furnaces are deployed in the foundry unit of PEDI, where personnel of the unit carry out metal forming and casting as part of machine or spare parts production process. Engineer Taiwo Adeyinka Taufik tells us more.
What we do here in the foundry units is metal forming, because in fabrication we have a lot of metal works that we can't join through welding, but all we have to do is to cast. And here at the foundry workshop we do all our casting. And how do we do our casting? We start from pattern making for those that did not have pattern. And if you have our pattern, then we do our charge calculation, whereby the charge consists of scraps, our cast returns, and our pure alloy. And we do that in the foundry workshop. We make use of two furnaces, which we have our rotary furnace and the induction furnace. The rotary furnace is a technology being achieved and discovered by NASENI itself, because this is our homegrown technology, and that's what we use. And why do we use this is because it's fuel fired. because we make use of diesel, which is less cheaper, and it's what we can see, which is a commodity, which is available within the market. And before we do our casting, we have to select our raw materials, which is our scraps. And when we do that, we do our charge calculation to meet up with the standard and to the demand of what they want us to cast. And before we do, even when we have our job, we have to do the chemical analysis. So from our chemical analysis, we know what we are going to charge. We know the charge calculation, the amount of carbon, the silicon, and the phosphorus that will be in our melt. And by so doing that, we bring everything here and we charge. During our charging, normally, basically for charging, we have a heat which we have to attain, which is about 1,005 degrees centigrade Celsius. And by so doing that, our steel will melt. But basically for the rotary furnace, we use to melt cast iron. And for the induction furnace, which is electrical inclined, we use it to melt our steel and alloy steel.
Quality control unit is where materials are characterized and analyzed. It is a sophisticated process of grading materials preparatory for production. Here is engineer Dr. Aderonke.
This is quality control unit where we characterize and analyze our materials. It involves 2 stages: sample preparation and photo micrograph. Here in sample preparation, we have metallographic cutting machine, where we section our material into smaller units. And if the material is so small or tiny that we are unable to handle it while grinding and polishing, we embed it on a molten press. On a melting press with the use of bakelite powder. We embed it on a molten press with the use of bakelite powder, which is a thermosetting material, to achieve this. From there, we move to grind and polish. We have different grid sizes of emery papers, starting from the coarse to the fine size that we use for grinding. After grinding, we produce to polish. We polish on an emery cloth with the addition of a diamond paste of different micron sizes in order to get a mirror-like structure. And finally, on this stage, we etch with the use of some chemicals, etchants, which are nitric acid, ethanol, hydrochloric acid, hydrofluoric acid, depending on the material, whether the material is ferrous or non-ferrous. If it is ferrous, we make use of niter, 2% nitric acid in 98% ethanol. And if it's non-ferrous, we make use of a Keller solution to achieve a dull surface before we proceed to the next stage. A photo micrograph. This is a inverted metallurgical microscope. And this, we identify and analyze the structure of the material. By this, from here, this is a nodular cast iron. It reveals the grains and the grain boundaries. And by this, we'll be able to know the property of the material, whether the material is ductile or is a hard material. This will enable us to be able to predict the performance of the material in service. And this is the BISCA micro hardness tester. This one is used to test for the adheritability of the material at micro level. The whole essence of this sample preparation and material characterization is to be able to improve the quality of our material, because by the time we are able to know the property of the material, we'll be able to predict whether the material is ductile or is a hard material, and we'll be able to know whether to improve on the material. By so doing, it will reduce material wastage, it will increase the quality of the material, it will make us be less dependent on foreign materials, and also it will increase our IGR.
Training and retraining is a culture at PEDI because of the need to upgrade production process in line with emerging technologies in advanced manufacturing.
Now, this particular machine here, what do we use it for? Basically, this machine is meant for training and retraining because it works on what we call term soft metal. What are the soft metal? They are metals that which you use without necessarily using a coolant. What can this machine do? This machine can do what they call facing, threading, chamfering, center boring, and so on and so forth. We have used this machine to do different kind of work. If This is the system, and then you have this interface. The bigger one has come with this interface where you can actually work, interact with the machine. But here, you work with this machine, and then you write your program, and you run it on the machine, and you can see this the machine works, and then you get your product done. This is one of the products which one of our students which are being trained actually wrote. The benefit of this machine is as what they call local area networking. Local area networking means is a system where you can actually write your program in your office at the comfort of your office, and through the central server you can actually run the program, and this machine will automatically recognize it, and you work and you begin to monitor it. Another benefit of this, it is very self-free, and it has high profile of what of quality control. Another point here where you can use this machine for, you can actually monitor your work, the progress of your work, and you can actually do what they call programming editing on the machine. That means you can, without actually shutting down the system, you can actually edit your program and make sure you get what you want. You can see these are the combination of programming, different turning, chamfering, turning, filler, and then you can see even threading is here. And the machine is capable of running about 4 different programs where you can link together, and then the two poles will automatically change itself. Is the benefit of it's fast, it's reliable, and it's very, very cheap. It's good for SIB companies and then other big companies.
And here is the Managing Director of PEDI, Ilesha, Engineer Dr. Bankole Olulade.
Our mandate is to develop engineering prototypes and their production systems and transfer same to private sector industries. The mandate of the institute, the missions of the institute, is to create, manage, and sustain a digitally driven design, production, and product support environment with a focus on developing small and medium scale enterprises for national development. In order to achieve this, PEDI is equipped by the federal government of Nigeria to have 3 workshops, 4 laboratories, and highly skilled staff, highly skilled and experienced staff. We have over 100 scientists and engineers. In all this, with the mix of this infrastructure and highly skilled and experienced staff, design and development of different products are achievable. Both home use products and products for industrial applications are achievable here. While we undertake reverse engineering, that is copying, having copy designs and things like that, we still do conceptual designs to cater for specific needs of the nation. For instance, if we have people who take akpu or abala or tuwo, we can design things to suit their needs. So we do conceptual designs as well as reverse engineer products. Any machine or equipment that will take Nigeria to that level of technological advancement is doable in PEDI, Ilesha. You will see from the workshops and the laboratories you have visited, you will discover that we have so many machines that are computer numerical controlled. One of them, if I may mention, is the vertical machining center. That machine is so versatile, we have two of them. The machines are versatile, they can handle 6 operations each, which is difficult for other machines to do. In fact, other machines are not tooled to do that. Now, with this equipment, with other equipments you have seen, you will discover that we can produce as much as anyone will be able to produce outside this country. Products that you have seen. We've handled things in the area of education, in agric, post-processing machines. We've handled things in handled industrial goods also. You see, automobile onboard diagnostic system, the rice milling machine, the rice distoner, the rice polishing machine. These are value addition in rice processing machines. We have groundnut extractor, which is also in the agri sector. If we go to the industrial sector, you will see things like laser engraving machines, the 3D printers, which can also be used in education, and the coating machines. All these machines can be produced. We have produced them. We have produced more of these machines.
What has remained constant in all the NASENI research institutes that I visited has been the amazing skills exhibited by Nigerian engineers and scientists with strong problem-solving abilities using available facilities and the right equipment. This is a testament to the solid technological background being laid by Professor MS Haruna. Now, the agency is working assiduously to ensure that the private sector keys into the technologies inherent in NASENI research institutes in such a way that can trigger commercialization and subsequent mass production of technology-driven products. Now it's time to produce what we consume in terms of electronic gadgets, automobile, and most importantly, the food we eat, which requires mechanized agriculture and the necessary infrastructure for value addition. This is NASENI Milestones, and it's time now to bring in the Executive Vice Chairman of NASENI, Engineer Professor MS Haruna.
It is again a great honor and pleasure to receive you here in Ilesha, Prototype Equipment Development Institute of NASENI. It is one of our recent institutes. It's relatively new, and we established this institute to help us and make our work easy in doing reverse engineering or backward integration of other equipment that are not produced by Nigerians, that are imported elsewhere, and we need to have those products in Nigeria. The institute is installed and provided with appropriate facilities for scanning, for additive manufacturing, equipment adequate to do reverse engineering, such as laser cutting, plasma welding, and plasma processes. It has the latest equipment for advanced welding anywhere in this country. So the idea is that if we see a machine and we need to reproduce that type of machine, we bring it to this center in Ilesha that have facilities to scan with precision, with measurement accuracy, with analytical capacity to tell us what materials are made of. And then as we dismantle this machine, it's recording the appropriate design to make it easier for us to develop computer-aided processes, computer-aided manufacturing, that through CNC machines can reproduce these components that are made of the parts that this machine is composed of, And in the process, when we produce our different components, it will be easier to assemble back and then have this machine. In the process of the design, it is possible that some components, after scanning and taking their appropriate measurement, it may be produced in a different institute of NASENI for Ilesha. It may be an electronic component that will take it to LD. It may be power equipment component that will take it to Okene. It may be some hydraulic or some pneumatic system operated devices that will take it to Kano for appropriate production. But Ilesha will give us the accurate and the detailed design simply through this process. So we call it also a center that will do rapid prototyping, because after producing this component, having their design computerized, it is easy. You have a file that with coded details of the design that any CNC machine anywhere in the world can produce these parts for you. Since after taking first design and having the first prototype, you can produce hundreds with the same precision, thousands and millions. And that file, that registered document, can be taken to anywhere in the world where they have CNC machine. It will produce exact component with exact precision, no variation, as long as the same materials is used. So in a nutshell, this is what PEDI Ilesha is established to do, to make it easier for us to do one of our mandate, reverse engineering of machines and equipment. That is what Ilesha is all about.
Thank you for watching NASENI Milestones. The program returns next week with a fresh edition of the program, as of course we make inroad into bringing people to think technology and be part of the homegrown initiative of NASENI. I am Kierian Umeayo. Bye for now.